Hello everyone, today I'm gonna present to you my assignment number 5 that focuses on Kaggle datasets about video game sales. So as you can see, I have a lot of null values there, so I dropped I dropped any rows with null values in the columns, and now as you can see, our dataset has like year of release, like North America sales, EU sales, and global sales, rating, and etc. And first, we need to understand our dataset better. We need to add some visualizations to see it better. So the first thing we did was to include use combination of matplotlib and seaborn and to see top 10 games by global sales using the bar plot, as you can see here, and also to see global sales by the genre, also with using the combination of matplotlib and seaborn. So as you can see, action is far more exceeding than the other genres. And this is the total sales per year, and in here you can see that ever since the internet started becoming the main part of people's life, it started growing exponentially. And here is the df describe, which is not really helpful in our case, but it's still important to see. And we saved it. Now we can see the correlation of all numerical values, and as you can see, like if a video game does well in like North America, it will do well in like EU and in globally globally too. So it's safe to say, like, if in one region it does really well, it will do well globally. So here we install some libraries to use, and now we are in the time series analysis. So we are importing necessary libraries for it, and as you can see here, I am getting the year to do the time series analysis, and as you can see that there is some missing years, so I use the reindex and populated it with like from the minimum to the maximum, and to populate the missing values I use interpolate. And now this is the same as this one, so, and now we are here in the STL decomposition. The first thing, our main time series shows total sales over time, like from 1985 to 2015, and there is clear upward movement starting around 2015, and no, starting around in the late 1990s and peaking around 2008 and 9. So here, and as you can see, the trend follows, like there is overall growth, but as the time went on, it started going down. And in season, we can see like we have 5-year segment here, like period is equal to 5, and we are checking if the sales are consistently higher or lower compared to the trend, and it seems like season seems more negative after 2010. And we have residuals, and it basically shows outliers, and as you can see, like in the year of 2000s, there is like really big outliers, which means that some games were much higher than the overall mean of that year, so it just became an outlier, and it was difficult to predict the overall trend for it. And now we have ETS. For ETS, I am putting 3 last years for train, and it's the rest of for test I am putting 3 last years, and for train it's the rest of the data. I had to rearrange indexes here too, because there were missing years here too. And ETS itself is predicting to go downward, the same as the test, although on different scales. So as you can see here, like we have test and we have ETS forecast. It seems like they are going on the same kind of downward slope, but they are on different values. And as for ARIMA, we just use the auto ARIMA function, and we can see that auto ARIMA is not as accurate as the ETS forecast. And we are calculating the metrics to see how wrong they were, like how like some RMCA, MA, MAPE, And basically we are seeing like ETS is far more accurate than the ARIMA, and like there is like 90% chance that this is like wrong, and 40% not chance, like 40% of the time it's wrong. And side by side, as you can see here. And also also for the next model, we are using KNN and linear regression. So basically we are first of all we are writing lag features for regression and classification, and we are writing like if it's bigger than the median, then it would be high sales, and basically we are training with the standard conventions, like 20% of the data is going to the test and 80% of the data is going to the training. So we use the basic way to do the KNN, and as you can see, like in the output, let me show you the output. So as you can see, KNN is this one, the orange line, and the linear regression is this one. So linear regression is this one, LR forecast, and LR is coming from this. So basically it's just using the train test split variables. And as you can see here, like linear regression, just by looking at it, is far more accurate than the KNN forecast, because the test line is black here. So, and this is the residual graph, and as you can see, like this is like KNN is getting a lot of negative values. Like the ideal situation for us is getting as close to the zero, and as you can see, like linear regression is somewhat close to the zero, and ETS residuals is really close, and KNN is far more worse than all of them. And as we can see, like KNN, like here, prediction class is predicting that the next outcome is going to be in the high sales, and linear regression says that the next outcome is going to be this amount of global sales in millions. And here is the residual errors. So as you can see here, like linear regression is, I mean, we figured out here, but linear regression is far more reliable and accurate in our case. That's all.